A sailboat leaves the pier and heads due west at 16 knots. After 30 minutes, the sailboat changes course to south 33 degrees west at 18 knots. Find the sailboat's bearing and distance from the pier after 45 minutes on this course. So our sailboat is going to leave our pier and it's going to head due west, so that's directly west at 16 knots. And it says we're going to travel in this direction for 30 minutes. Okay, a knot is a nautical mile per hour, and so if 30 minutes pass and we're going 16 knots, that means that we've gone 8 miles, 8 nautical miles. And so now at this point, we're going to change direction. So we're going to draw a little north-south line. And we're going to change to south 33 degrees west. So that means this angle is 33 degrees. And we're going to travel at 18 knots for 45 minutes. So 3/4 of 18 would be 13.5 nautical miles. And so the question is, how far are we at this point from the pier? We'll just call that distance D. And we want to know what is the bearing of the sailboat from the pier. So we want to find this angle in order to get our bearing. So the problem is that the triangle that we've drawn is not a right triangle. And so we're going to have to divide this diagram up into right triangles in order to be able to solve our problem. So first of all, we could make a little right triangle right here. And we know a little bit about this. We know that this side is 13.5. We know that because this angle is 33, that this angle would have to be 90 minus 33, which would be 57 degrees. So using those two facts, we can find this side A in the triangle and this side B in the triangle. To find side A, let's use our 57-degree angle. We know the hypotenuse is 13.5. We want to find the adjacent side. So we're going to use our cosine function. The cosine of 57 degrees will equal A divided by 13.5. So solving for A, we're going to multiply the cosine of 57 degrees times 13.5. So 13.5 times the cosine of 57 degrees gives us that A is 7.3526. And now to find B, B is opposite our 57-degree angle. So we're going to say the sine of 57 degrees would be the opposite leg, which is B divided by 13.5. So B is going to equal 13.5 times the sine of 57. And so B is 11.3221. Okay, so how does that help us? Well, now if you look, we have a big right triangle that we know a little bit about. For example, we know that this whole side will be equal to 8 plus the 7.3526. So that side of our triangle is 15.3526. And so we can find our distance D using the Pythagorean theorem. D squared is going to be equal to 15.3526 squared plus B, which was 11.3221 squared. And so D is going to equal the square root of this. 15.3526 squared plus 11.3221 squared is 363.892, we'll say, and then take the square root of that. And we come up with D is 19.076. So our distance is approximately 19.1 nautical miles. Okay, so next we want to find our bearing. So in order to find theta, let's first of all go back in our triangle and find alpha. We can say that the tangent of alpha is equal to opposite, which is B, which is 11.3221, divided by our adjacent side, which was 15.3526. So alpha is going to be the inverse tangent of 11.3221 divided by 15.3526. So we get alpha is 36.408 degrees. So that's what this angle in the triangle is. So for us to find theta, which is our bearing, notice that if we went all the way around, we would be at 270 degrees. So 270 degrees minus the alpha that we just found gives us 233.6 degrees approximately for our bearing. Now, we could also write this a different way. For example, we might want to start south and then measure to the west. So another way that we could say our bearing is we could say we went south, and then if this angle is 36.408, 90 minus 36.408 is 53.6 approximately. So we could say we moved 53.6 degrees west. And that would be another way that we could write the answer for our bearing.